All right. Perfect. So saying we will cover the ship propulsion, model testing, and propulsion device. Next week we will start the textbook 2. Any question? No, then we can start with the needs. Today I will give a lecture about React test and refer resistance and powering chapter from the book. These are our contents. Start from model-based theory. So the model-based theory was invented by William Crookes in 1868. Since then, it was possible to predict the ship resistance based on the model test by using dimensional analysis and scientific methods. People performed the experiment from small-sized models to predict real ship resistance. This is the model test based in video example, but I will skip this. The key point is we conduct the experiment using smaller size ship to predict the real ship resistance or performance. Okay, dimensional analysis is the relationship between different physical quantities by identifying their primary dimensions and units of measurement, and setting these dimensions as calculation or comparison are performed. In mechanical engineering, there are 3 primary dimensions: mass, length, and time. So we combine these parameters and make up. We express a variable. For example, a simple pendulum case, the relevant physical quantity of the tension of the string are mass and length and gravity constant. And the gravity constant is combination of length and the time. Okay, for applying dimensional analysis to the ship resistance, it depends on following physical quantities: the fluid density, speed, and size of body, viscosity, and gravity constant, and the pressure. But in general, we don't consider the pressure as a variable. So resistance is function of this phi value, and using pi theory, we can reduce variables. So, for example, it has 6 variables. Okay, it has 6 variables. It's total 6, and the primary dimension is 3 penalty. So it means we can reduce to 3 non-dimensional parameter case like here. So the dimensionless resistance can be expressed by Froude number and Reynolds number. And similitude allows us to predict the quantities to be expected on the real ship from measurement. So in its functional relationship between a set of non-dimensional groups. And there are two main types of resistance, which are frictional and residual, and plus minor resistance. So first, the frictional resistance or viscous resistance is due to the motion of the hull through a viscous fluid. So it's offered by the water surface. And second, residual resistance is composed with wave and eddy. Wave is due to the energy that must be supplied to the creative wave, and eddy case is due to the energy carried away by eddy shed. So these are afforded by the wave on the surface. Last one, the binary resistance is due to the air acting on the above water part of the ship. So usually protect the structure above the water. But we can neglect this term because it's smaller than other. For dynamic similarity, friction and residual resistance cannot be satisfied at the same time. So the Proust hypothesis said that the total resistance is the sum of residual and friction resistance. And the practical method is to deal with these two terms separately. So in the previous slide, we derived the dimensionless resistance as expressed by Froude number and Reynolds number. So we are going to use these values, and we are going to use the Froude number to calculate to predict the residual resistance coefficient. So the Froude's law of the comparison is follows. And ships of different size, model and real ship will have the same residual resistance coefficient. And so the CR is same if they are moving at the same value in the parentheses here. And such speed is called the corresponding speed, and we call the Froude number, also non-dimensional. Okay, we are going to use Reynolds number. For a deeply submerged body, the frictional resistance is predominant. So using Reynolds number, we can predict the frictional resistance coefficient. And this step will be the same, the model and the sheet, given the parameter in the parentheses is the same. So the parameter is called the Reynolds number. And in these two slides, one is when we select the same Reynolds number and Froude number, we can predict the resistance coefficient because it's the same as ship and the model ship. It is a procedure of predicting ship resistance. First, we have to make a smaller model. So the model is made to a linear scale of lambda and run over a range of corresponding speeds. So to more explain detail, linear scale ratio lambda is defined as the length ratio of ship to model ship. So we can see it has a linear relationship, but corresponding speed is not linear. Since we can see the square root of lambda term here, and the Froude hypothesis said that total resistance is summation of these two, residual and frictional resistance. For dynamic similarity, then it must be dealt separately. So that's why we use the Froude number and Reynolds number respectively. By using Froude number, we can predict the residual resistance coefficient (CR). So when we select the same number of Froude number, we can use this relationship. By using this, we can derive corresponding speed v is proportional to square root lambda. This is what there is square root lambda term, so it's not linear. And next, we can obtain the total model resistance from experiment or simulation. And the frictional resistance of the model RFM is calculated assuming the resistance to be the same instead of a smooth flat plate of the same length and surface area as the model. So now we are known two values. Left hand side in this equation, and second term in the right hand side. So the residual resistance of the model is found by subtraction, and then we know all the whole count of model. So we can predict using this value, we can predict the real shift resistance. Residual resistance of the real shift is calculated by just multiplying lambda's cube, and the frictional resistance shift is calculated using a frictional coefficient chart. There are many famous frictional coefficient charts. You can use it. And then total shift resistance is just summation of these two terms. We can obtain power requirement by multiplying velocity of the ship. Now we can select the motor, or we can design a performance for the real ship by using models. Okay, this is the end of my presentation. Thank you for listening. Question? Question? Third floor of this building, there is a functional ship model around the corner. Have you seen that model? Yes. Yes. No. No. Yes, again. Yes, again. Oh, let me see. Right. Upstairs, around the corner, there is a container ship model about this size from Samsung Heavy. And that is, you can say, for decoration model. And if you go to Eureka building, who are staying in Eureka building? Some of you. At first floor Eureka building, there is two big wooden ships, about more than 10 meters. I guess 10 meters is about this roof size. Wood made model is there are two. One is staying in like this one. The other one is uprighted because it's too long. And those wooden model is the model for towing tank. 10 meter, more than 10 meters long. Right? But see,
Your ship is costs more than 300 meters, and that ship is only 10 meters model ship. I can see that the scale ratio is 30 to 1. Right? Even though the model, wood model is big, right? The real big ship is big. Now, if we know that somehow food is very difficult or complicated theory behind, but we know that residual resistance coefficient, yeah, the same for ship and model. Then we know that the speed of the ship, because it is from the contracts, and we're trying to design the ship to meet the contract guarantee speed. And length is also, we already finished my design, so the length is fixed. And model scale, probably choose, usually there is around this scale, depending on the leadership size. Because of the model test Beijing, the towing tank, there has a limitation of size, so that you cannot make 20-meter long model ship, right? Or wider. Right? There is a maximum size for the model size, wood model size, so that you are around this scale can be depending on the model towing tank, because in say Samsung has a towing tank around here in this town, and Chris also have a model tank. So there are big two tanks. Chris has a 200-meter long. Samsung has a 300-meter long towing tank. So that depending on the size and also you have a model scale. Then you choose the length of the model. So this is fixed. Then you can calculate the V of the model test.